Because why not? Yeah, I am. Okay. Hey, folks, I want to take you through a much quicker way to do this problem. On Friday, we looked at it and we split it up, okay, into two inequalities, and then we split that up into two equations, and then we worked through it. Now, is it okay if I did something like this? And the answer that you're supposed to give me is yes. Oh. And, oh, absolute value tells me that maybe I should do that again. Oh. And then I just solve this inequality. Okay. So what should I add to this side and this side? 1. Oh, chow. That's one of my intervals. Oh, chow. Oh, and then do this thing again. Okay. What should I do first? I could distribute the negative or... No. Order of operations. I could divide by a negative. Oh, so what would that do to my inequalities? Bam. Slam. Right? Make that a -2 and that a -5. Oh, so then that's x minus 1. Let me drag this out of the way. Oh, chow. So if I add 1, -1, x, -5. Oops, -4. Slam. All right, so when we talked about this last week, we said, oh, this is an absolute value shifted to the right 1. And we want to know where it's between 2. There's 2 and 5. Well, we now know that that's true. What would the endpoints of that be? 3 and 6. Yeah. Cool. And then the endpoints on the other side. -1, -4. Ooh, that was too easy. Okay, sweet. You're welcome, Caillou. Let's roll with some new material here, folk. We're going to go with number 4. And number 4, I've moved some things around here a little bit, is 2x minus x squared greater than or equal to the absolute value x minus 1 minus 1. Is that ugly? Nod your head. Yeah, it's ugly. Okay, but really, all I want to do is make one side equals 0, and then I'm going to work with that. So I'm going to make one side equals 0 here. I'm going to take negative x squared. I'm going to bring it out in front. I got a positive 2x. Then I'll have a minus the absolute value of x minus 1 and plus 1. And that's all going to be greater than or equal to 0. Anybody want to argue about whether or not that's true? Okay. Algebraically, I didn't do anything wrong. Okay, now I'm going to duplicate this, but what am I going to do with that absolute value? What do you mean flip it? Yeah, one's negative, one's positive. So let's go, one's negative. Okay, so that'd be minus the opposite of what's in here. Okay, the opposite of what's in there. Okay, so that would be 1 minus x. That's the opposite of what's in there. Now on the other side, I'm going to take and I'm going to subtract what's in there. Right, I didn't change anything there. So I have a positive of that, I have a negative of that. Now I'm going to add like terms. So when I combine like terms, it looks like I have a minus 1, which will cancel with that. And then I have a, is that a minus or a positive x? Yeah, I have a plus x. So I have negative x squared plus 3x greater than or equal to 0. Okay. Over here, when I simplify, I have a minus x and I have a plus 1. So that would be negative x squared. How many x's would I have? 1x plus 2 greater than or equal to 0. Right side. Okay, on the left side, if I factor, I'm going to take out a negative x. What do I have left? X minus 3. Okay, so just ignore the greater than or equal to for a moment. Where would this equal 0? At what two values? X equals 0 and 3. Okay, so I've got some idea of what this one would look like, right? I know at 0 and at 3. Would that parabola open up or down? Down. Okay, so now I want to just identify here. Where would this graph be above or equal to 0? Well, here to there. And I'm inclusive on both ends because it's greater than or equal. So I know that the solution to this one would be 0 to 3. Okay, now, because I have both of these, I have to find the domain for the other one and then overlap them. So I want for you and a neighbor to find the domain on the other side, and then we'll talk in a minute and we'll overlap them. The children are working, so I'm going to work quietly. Vector out a negative. I know. Who knows the numbers? What are the numbers? So this same process can be done in just a different way. I could use what's called testing number lines. Okay, I know that at 0 and at 3, this function, whatever it was, what was it, negative x squared plus 3x, I knew that it would be greater or equal to 0 at those 2 points, right? Equal here, equal here. What you could do is you can pick points, pick a number in between. Well, let's choose 1. If we plugged 1 in there, we could find out whether or not that value would be above or below. We could test it. And if we tested it and plugged a 1 in there, we'd get negative 1 plus 3. Would it be greater than or equal to 0? The answer to that is yes. So we could say it'd be true in between there. So really what we're doing is we're graphing it, but just testing some values. If I tested a negative 2, well, that would be false, right? Because if I plug in a negative 2, I'd get a negative number, which is not greater than or equal to 0, and same thing here. So what I've shown by testing intervals is that between, including those two values, this would be the domain of satisfiable numbers, inputs, right? Which is the same as what we got down here, right? From 0 to 3, inclusive on the ends. You could do the same thing over here. You're going to see the same result, right? We had a negative 1. It equals 0 there. We had a positive 2. It equals 0 there. If we plug in a 0, that function would be positive or true. If we plug in a negative number less than 1, we'd get a negative number, which is false. And then same thing, if we plug in a number greater than 2, we'd get a negative number, which makes that statement false. So it's two different ways to test it. You could test intervals that way. You could graph and think of it logically. And then, of course, at the very end, we would overlap those two domains and get our answer of this set builder notation. What does this thing right here mean? That means a coordinate. Yes, you're right. But that means all coordinates. All coordinates such that y is greater than the absolute value of x. So here's the absolute value of x. Drawn pretty well, I'd have to say, considering I was on this side of the board. Okay. What coordinates would satisfy greater than the absolute value of x? Well, everything that's above it. Right? This shading space would go on forever. To the north, A. All right, how about the next one? Let's go with a different color just to keep it real. Oh, what is this equation? That's a parabola. Yes, correct. Thanks, Eddie. That was really nice. Thank you. Okay, so I'm going to graph that parabola. Okay, it's got a y-intercept of 2, and it opens downward. And I want to know all values that are what? Greater than or less than? Less than. So I'm going to shade below. Shade below. Be a good child. Shade below. Now, what's the important distinction between the first two examples? There is a distinction. And right now I've got one of them wrong. What should I do to the first one that I haven't? Dashed. Yeah. Yeah. Right? Because it's greater than, not greater than or equal to. And that, folks, is how you earn thousands of dollars in one lesson.